Welcome to lesson number 4, Properties and Changes of Matter. Our lesson objectives: identify the states of matter, construct particle diagrams for solids, liquids, and gases, determine the phase of a substance at STP using table S, and finally differentiate between physical and chemical changes. So let's first look at the states of matter. When matter is in the solid form, it has a definite volume and definite shape, as seen here in the particle diagram. So when we place this solid, this red solid, in this space, it retains its shape and volume. Notice the particles are moving. They're moving slightly, but they are vibrating in place. And the symbol for solid after a chemical symbol would be S in parentheses, indicating it's in the solid state. Liquids have a definite volume, just like solids, but they take the shape of a container. So whatever shape the container is, that's what shape they're going to take. Notice that the liquids are more spread out than the solid, and the particles are moving more. They're in constant motion, sliding past each other, and that's why liquids are fluid. And we identify liquids using the symbol L in parentheses. Gases have no definite volume and no definite shape. They are always going to spread out and fill a container, as you can see here. It doesn't matter how many particles they have, they're always going to end up filling the container. They're also what is called compressible. So we can take the particles and compress them, meaning push them closer together, as in the example here with the piston. Gases have the greatest amount of movement, as you can see in the particles, how much they're moving. And the symbol for gas is going to be G in parentheses. So let's check your understanding. Can you identify the states of matter? And can you construct particle diagrams for solids, liquids, and gases? Now let's focus on determining the phase of matter at STP. Because at different temperatures, a substance can either be a solid, liquid, or gas. So it can change the phase of matter that it's in. So scientists determine what is normal conditions of temperature and pressure, called standard temperature and pressure, which is called STP for short, standard temperature and pressure. And the standard temperature, which we'll focus on now, we'll come back to pressure later on in the year. The standard temperature is going to be 0 Celsius, which is equal to 273 Kelvin. So the reference table, all the values there are based on standard temperature and pressure. Okay, now let's look at using table S to determine what phase of matter is a substance in at standard temperature and pressure, STP. So here's an example. What is the phase of matter of bromine at STP, standard temperature and pressure? So first, what I would do in a question is I would circle STP and write the standard temperature from table A, 273 Kelvin. So now I have a reference point. Then I would locate bromine on table S, which is atomic number 35. Here it is. And we go across and we see we have the melting point and the boiling point. So when the temperature reaches 266 Kelvin, bromine melts. If something melts, it's going to turn into a liquid. And then at 332, it's going to boil, which means it turns into a gas. So what we want to do is we take STP 273 and we say, where does that fit in terms of these numbers? Well, 273 is in between 266 and 332. Since it's in between, we're going to say that it is in the liquid phase. Why? Well, it's past 266, so once it passes 266, it has melted, which means it went from solid to liquid, and then it has not made it to the boiling point. It has not turned to a gas yet, so it is in the liquid phase. And so when you're trying to determine the phase of matter, again, you're going to look up the element on table S, and then you can use this in your notes for assistance. And so if the temperature is lower than the melting point, so if, let's say, STP is 273 and it's lower than the melting point, then it hasn't melted yet, and so the resulting phase is solid. If the temperature is higher than the melting point, but it hasn't reached the boiling point, we say it's in the liquid phase. And then if the temperature reaches the boiling point or exceeds it, we know then it has boiled already and it would be in the gas phase. And now lastly, let's look at the changes of matter. So we'll look at physical and chemical. So first we look at the physical properties or changes of matter. These are characteristics that don't change the substance. The substance stays the same. So again, no new substance is produced. That's how we identify a physical property or physical change. Some examples of a physical property or a resulting physical change: density, crushing, ripping, breaking, solubility, conductivity in terms of electricity or heat, the melting point or boiling point, any phase change going from a solid to a liquid to a gas. No new substance is being produced. It's still the same substance. For example, if you have water in the solid form as ice, and then you melt it to make it liquid, it's still H2O. It's still water. So how do we look for a physical property or change? What are the signs? Again, it's still the same substance, but it could be in a different form, shape, size, etc., or different form or state of matter. So going from a solid to a liquid to a gas, as in the example here. So this is water, so it's still water even when it's in the solid or liquid phase. And some words to look for in your questions. Look for things like dissolves, phase change, melts or boils, is a solid, liquid or gas, etc. Chemical properties or changes. These are characteristics that change the substance. So a new substance is being made. And some examples are reactivity, if something's reacting. Flammable, if we're burning it. Corrosive, oxidizing, another word. Bubbling. These are all examples of chemical properties and or changes. And so how do we determine that? What are some signs of a chemical property or change? Well, a new substance is being made that has different properties than its original elements. So some words we can look for in our questions. Reacts with water, etc. Combusts, corrodes, meaning rusts. These are all chemical changes that are going to produce a new substance. So some other examples, as I mentioned, rusting, so rusting iron. That would be a chemical change because a new substance is being made. In this case, iron oxide. Dissolving in water. If something dissolves in water, the original properties are still there. So salt dissolves in water. It still has the properties of water and the salt. So that would be a physical change. Burning a log. When we burn something, we're creating a new substance. So that would be chemical. And last one, crushing a compound. When you crush something up, it's still the same substance, just in smaller pieces, kind of like tearing up paper, and that would be a physical change. Let's check your understanding. Can you differentiate between physical and chemical changes? At this point, you should be able to identify the states of matter, construct particle diagrams for solids, liquids, and gases, determine the phase of a substance at STP, the standard temperature and pressure, using table S, and finally, differentiate between physical and chemical changes.